We now talk about a magnetic field created by a solenoid. So what is a solenoid? So solenoid looks like this. The current is entering into the wire right here. And then the current moves around. We can use the right hand rule to find the magnetic field. And the current comes out here. So we want to find the magnetic field because of the solenoid. So the field is really weak here. So the field is weak here. And we just talk about the field inside the solenoid. So we are going to talk about the field inside here. So we have to use Ampere's law. So first we have to define a loop. So we define this loop in green. So this is the loop. Now once we have this loop, we have to find the dot product on each of the four edges of the loop. So let us first take this edge. Now on this edge, so this loop we will take like this, that goes like this. So on this edge, you see the magnetic field is right here. You see this, the magnetic field direction is this way and our loop is going this way. So we have that B vector dot ds vector. This is equal to B ds cos theta. So for this side, say this side is side 1, we have theta as 90 because the loop is going up and the field is going in this direction. So theta is 90. So this is 0 for side 1, this becomes 0. For side 2 right here, we take the magnetic field is really weak. So that is B is approximately 0. So if B is 0, then B ds cos theta becomes 0. So for 2 also, there is no contribution of magnetic field. Then we come to side 3. When we come to side 3, you again see the magnetic field is given by these blue lines. So magnetic field is going like this. So it is again making an angle of 90 degrees with the loop. So cos theta is again 0 because theta is 90. Just like in 1. So for 3 also this is 0. So we end up with 4. That is the fourth side right here. Now for the fourth side, we know that magnetic field and now the loop are in the same direction. You can see the magnetic field given by blue and this green loop are in the same direction. So for fourth, it is just equal to B ds cos theta becomes 1. This becomes 1 because theta is 0. So this becomes equal to B ds. Now let the total length of this entire solenoid be L. So this total length is L. So if the current through the wire is I, then the total current passing through this L is N times L, where N is the number of loops. So that is the amount of current which is flowing because you're looping the wire over. So this is the total current flowing. So let us write this down. So if the current flowing in the wire is I and the wire passes through the loop N times, the total current is Ni. So you use the Ampere's law. So instead of current, you use total current here. You know that B vector dot ds vector is just B ds. You take B out, integrate over ds. Now you have the entire length L. You plug in L and this is equal to mu naught Ni. So you get B is equal to mu naught Ni over L. Mu naught is permittivity of free space, N is the number of loops, I is the current flowing through the solenoid, and L is the length of the solenoid.